Okay, grade 8. We are now doing, what are we doing? We are doing lesson 5. You see there? Lesson 5. Solve multi-step equations. Okay? And you have new vocabulary. You must know what null set means. You must know how it looks like. Okay? You must understand these symbols right here. You must know how to use these words when you're explaining. So, lesson 5 of chapter 2. So it is chapter 2, and we are on lesson 5. It starts on page 153 of your book. Okay? All right. So let us read what they say over here. It's always important to read. Some equations contain expressions with grouping symbols. To solve these equations, first expand the expression using distributive property. You learned distributive property in grade 7. Okay, I will remind you what that means. So, you're going to use distributive property. Then collect like terms. Like terms means either numbers together or variables together. Okay? Like term means they must look the same. Okay? That's if you need to. And then you need to solve the equation using the properties of equality. You must know what distributive property means. You must collect like terms. You must use properties of equality to solve. So this you must do to become successful. All right, so let us look what lesson 5 wants. I have too much work here. Okay. All right. I asked what is a multi-step equation because I was told to solve a multi-step equation. Okay. You will have variables on the left side and the right side of the equation. We saw this in lesson 4. You must solve using properties of equality. We saw this in lesson 2. The variables must be the same. That's why we said they're like terms. Okay? So the variables must be the same on each side. I cannot have A and B on the... I cannot have A on the left side and B on the right side. No. My equation should have the same variable. A and A. B and B. Because I will need to collect the like terms. Also, I may use distributive property. Depending on the question, I may use distributive property. And this you learned in grade 7. Okay? So I have reminded you where we did these things from. Okay? All right. Now, in this question, in this lesson, you also need to know how many types of number of solutions. How many types? How many is a number? You need to, when you see the question, how many, it means a number. So how many types of number of solutions do we have when solving equations? So, what does this question say? You will be given an equation. You will solve. At the end, there will be an answer. This answer will tell you how many numbers of solutions you have. Okay? So, I wrote here, there are only 3 types of number of solutions. You must know these 3 types. So first of all, how many types of numbers of solutions do we have? We have 3 types, okay? That we can get when we solve equations. Again, there are only 3 types of number of solutions that we can get when we solve equations. You will see what I mean when I explain more in the next steps. Name the 3 types of, so you need to give the name of these 3 types of number of solutions. So name the 3 types of a number of solutions we have when solving equations. So the 3 types of number of solutions we can get when solving equations are, you can either get a null set, or you can get a one solution, or you can get an identity solution. Okay, so the number of solutions have 3 names: null set, one solution, identity. These are the 3 types. Okay, now you need to know what I mean by null set. How does it look? How will you know? You need to know this. What does it mean when you say you have a null set? What does that mean? You need to be able to explain that, okay? All right. So how do you do that? So that's why I wrote this question. Justify each type of solution. So when you have a null set, okay, what does that mean? It means there is no solution. Null set means I don't have a solution. That's what null set means. Or you can say there is no solution. There is no solution. That means you solved and you didn't find an answer. And how will you know you didn't find an answer? You will see your left side does not look like the right side, because the left side of your equation is not equal to the right side. When the left side is not equal to the right side, then you will say you have a null set. So how will you know when you solve and you find A is not C? So this is no solution. Five is not -5. These are 2 different. One is positive, the other one is negative. No solution. This is a different fraction from this one. Okay? Even if it is positive, it doesn't matter. They don't look the same. So they are not equal. A half is not equal to a quarter. So no solution. So it can either be letters, it can either be numbers, it could be decimals also. 0.3 is not the same as 0.333. These are 2 different numbers. Okay? Because my left side does not look like my right side, I have no solution. Now, how do you write the null set? The null set is written like this in math, or it is written using the set notation, like that. These are the 2 ways we write the null set. So when you see this sign, it means there is no solution. When you see this set that is empty, it means there is no solution. Okay? All right. Now, how do you know you have one solution? One solution, you will need a variable and a number. Okay? So, variable and a number. Okay? So, you will have x equals to -0.6, or you have m is equals to 10, or you have y is equals to 1/8, like this. It doesn't matter. You have z is equals to -4, or you have -4 is equals to k, like that. So it doesn't matter. As long as you have a letter on one side and a number on one side, then you have one solution. That is how you know. Because you found an answer, because your variable has an answer, because you have one variable and one answer. So that is why you're calling it a one solution. Now, identity is when the left looks like the right. A equals to A, -1 is equals to -1, 0.2 is equals to 0.2, 5 is equals to 5, like that. As long as the left and the right look the same, then you have identity solution. So here you will say because, no, we cannot start our answer with because. Give me 1 second, let me erase. So you will say I have infinitely many solutions. I have infinitely many solutions because the left side of the equation is the same as the right side. Is the same as the right side. Okay? So what does identity mean? You have infinitely many solutions. That means there's not only, you have so many solutions you cannot finish to count. That's what identity means. It looks the same. They are identical, like identical twins. Okay? So you can either have a variable, the same variable on the left and the right, after you have solved. That means after you have completed solving, the last step is a variable equals to a variable, or a number that is equal to another same number. Then you will say identity. So I have infinitely many solutions because the left side of the equation is the same as the right side of the equation. Here you have no solution because the left side of the equation, please write in English, of the equation, the left side of the equation is not equal to the right side of the equation. Okay? No solution, they don't look alike. Infinitely many solutions, they should look the same. One solution, one letter, one number. Okay? Let's start solving. So we solve. Since I have brackets, I know I'm going to do distributive property. So I draw my bridge. And then I'm going to do distributive property. This is -5. I am going to multiply with 12. And then -5, I am going to multiply with positive m. So that will be -60 minus 5m is equal to 40. How do I know? Because a negative times a positive is a negative. And a negative times a positive is also a negative. Okay? Then I continue solving. I'm going to move my number to the right. Since it is negative, I will add 60 on both sides. I am doing addition property of equality. So this will become 0 because of additive identity. A number plus its inverse gives me 0. What am I left with? -5m is equal to 100. What do? I divide both sides by -5. This goes away. M is equal to -20. Okay, so the question says solve the equation. Solve the equation means solve and check. Even if the question doesn't tell you, you must solve and you must check. Now let us check if our answer is correct. So we have -5 bracket 12 plus m is equal to 40. negative 5, 12 minus plus negative 20 plus negative 20 is equals to 40. Plus and minus becomes minus. So negative 5, 12 minus 20 is equal to 40. 12 minus 20, should that be negative 8? So 12 minus 20, that should give me negative 8. So negative 5 bracket negative 8 is equal to 40. Negative 40 is equal to, no, positive, because a negative times a negative is a positive. So 40 is equal to 40. Now, I have one type of solution. Why? Because I have a variable and a letter. So the name, this will be one type of, yes? Or one solution. One solution. Okay? And then how do I know? Because the variable can only be negative 20. It cannot be any other number. It must be negative 20. If I put another number, my check will be wrong. Okay? Because the variable can only be negative 20 and not any other value. And not any other value or any other number. Okay? All right. Let us do another example. All right, let us do this. So we draw our bridge. We do distributive property. You see me drawing my arrow and going with the sign in front. You take everything so that you don't make a mistake. Okay. The answer to my first circle is 18 times 15. 18 times 15. Sorry, 8 times 15, not 18, is 120. So 120 minus 48C. How did I know it was negative 48? Because 8 is positive and 6 is negative. 8 times 6 is 48. Then I do this. Negative 3 times 16, I think that should also be negative 48. C. Now let us see if we are correct. Negative 3 times 16. Negative 3 times 16 is equals to negative 48. Okay? Negative 3 times positive 40 is equals to negative 120, because a negative times a positive is a negative. All right. So then what do I do? What do I do here? I think this should be supposed to be a negative here. Sorry. This is supposed to be a negative over here, so that this becomes a negative. Okay? All right. So then you continue solving. I move my letters to the left and my numbers to the right. So I will add 120. Add 120. I will add here. This is the one I am moving. So I will move plus 48C plus 48C. Okay? What do I get here? 0. 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 How do I know? Negative 120 plus 120, a number plus its opposite is 0. So here, both of them are 0, is equal to 0. Aha, now you see? There you go. And this is my answer. So I know this is an identity solution. Okay? Now, okay? There is an identity solution. Do you check? So identity solution means you can use any other number you want to make sure it is identity when you're checking. So I can use 1. I'm going to use 8 bracket negative 15 minus 6 bracket C, close the bracket, is equal to, then I put bracket again, 16, no, there's a negative 3 here. So negative 3. So negative 3, and then bracket 16, bracket C, plus 40. I can use any other number and I should get the same answer on the left and right. So I'll use 1. It is easier to multiply with 1. So this will be 8, negative 15, minus 6 times 1 equals to negative 3, 16, bracket 1, plus 40. So what does this become? 8, negative 15, minus 6 is equals to negative 3, 16, plus 40. Okay? So I can do this in one step in my calculator. 8 bracket negative 15 minus 6. I close the bracket. I got negative 168. Then I need to do this part. Negative 3 bracket 16 plus 40. Close the bracket. Negative 168. And there I'm correct. So when you get identity, choose another number to put over there. Always use 1 because it's easy to multiply with 1, okay? So when you have identity, check by using 1. So now, this is an identity solution. An identity solution. How do you know? Because my left side of the equation is the same as the right side. So I have infinitely many solutions. Infinitely many solutions. Okay? So that's how you do that question. All right, so let's do this. Draw a bridge. Okay. Here I will take negative 2 and I will multiply with 3z, and negative 2 and multiply with negative 6. So I have 10z minus 6z plus 12 is equal to, how did I know it was 12? Negative 2 times negative 6 is positive 12. Negative 2 times positive 3 is negative 6z. Then here I'm going to do 4 with 3z. I'm doing distributive property. This we learned in grade 7. 4 times 3z becomes 12z Positive times positive is positive. Positive times negative is negative. 4 times 6 is negative 24. And then this is by itself. 8. Why is it? This should be Z. 8Z. Okay. All right. So let's continue. All right. So here I can put this together. 10Z minus 6Z is 4Z plus 12 is equals to, then I put this together. I have 12Z minus 8Z minus 24. Now, what is 12Z minus 8Z? 4Z. 4Z minus 24. And here I have 4Z plus 12. I don't even need to continue. This does not look like this. Even if I solve, I should already know I have no solution. But let's continue. Letters on the left, numbers on the right. So I will write minus 4Z, minus 4Z, minus 12, minus 12. Okay? This box goes away because it's 0. And also this box. And this box also goes away because it is 0. So on this side, I have 0. And then on this side, this is 0. And negative 24 minus 12, negative 36. 0 and negative 36 are not friends. They are not the same. So this is no solution. So no solution. Do you need to check? Yeah, you always need to check. But, yeah, you can check using 1. Why not? Check using 1. 10 brackets Z minus 2. 3Z minus 6 is equal to 4. 3Z minus 6 minus 8Z. So here you do 10 bracket 1 minus 2, 3 bracket 1 minus 6 is equals to 4, 3 bracket 1 minus 6 minus 8 bracket 1. This becomes 10 minus 2, 3 times 1 is 3, minus 6 is equals to 4. 3 times 1 is 3, minus 6. There's a bracket over here. And then minus 8. Just like that. Okay? Then I solve this. 3 minus 6 is negative 3. So this is 10 to negative 3 is equal to 4. 3 minus 6 is negative 3 minus 8. This is 10 minus 6, which is equals to 12 minus negative 12 minus 8. 4 times negative 3 is negative 12. And then I need to subtract 8. 10 minus 6 is 4. Negative 12 minus 8 is negative 20. There you go. So for no solution, these two, your check will also have different answers, as in your left and your right will not look the same for both your solving and for your checking. For this to be correct, these two should not look the same. The left and your right should not look the same here and also in your check. Okay? So naming the number of solutions I got after solving, no solution. Why there is no solution? Because the left side of my equation does not equal the right side of the equation. The right side of the equation. Okay? All right. Then there is this one. Solve the equation. Name the number. Check if name the number of solution and justify your answer. So we're doing this for the fraction. All right. So I'm gonna do here distributive property. Positive 2 goes with 3a. Positive 2 goes with negative 1. This side I don't need to do distributive property. Half a bridge. Half a. When we multiply fractions, you should know this is 2 over 1. So you just multiply. That becomes positive 6 over 4a. And then 2 times negative 1, negative 2, is equals to a quarter a plus 6. Can I add this? No. Why? Because my denominators are not the same. Make this denominator the same. How will I do that? I will multiply my denominator by 2 and my numerator by 2. So my new fraction is 2 over 4a plus 6 over 4a minus 2. Remember this from grade 7 and grade 6 is equals to a quarter a plus 6. 2a plus 6a is 8a. 8a over 4 minus 2 is equals to a quarter a plus 6. Bring my letters to the left, my numbers to the right. So I will minus a quarter a from both sides. And I will add 2 on both sides. I told you do very few steps. If you do very few steps, you'll have very few mistakes. So this and this one go away. Easier to solve this. The 6 plus 2 is 8. And then here we have what? I can subtract. 8 minus 1 is 7. So I have 7 over 4a. I can subtract them. How do I know? 8 over 4 minus 1 over 4. 8 minus 1 is 7. And we don't touch the denominators. All right. Now I need to find a. I do multiplicative inverse. 4 over 7. And I multiply both sides with 4 over 7. This becomes 1. This becomes 1 because a number times its multiplicative inverse is 1. A is equal to 32 over 7. Change this to an improper fraction. A is equals to 7 goes into 32 how many times? 4 times, yes. 4 times. And what is 28 minus 32 minus 28? 32 minus 28 is 4. So 4 over 7. You can do that even here. But why are you using the calculator? Just being lazy. Don't make your brain become shift equal, and then shift 4 and 4 over 7, 4 and 4 over 7. You can do this work without the calculator. And then you check. Do the check by yourself. I'm not doing that for you. Put it over there. So this becomes a half bracket a plus 2, 3 over 4 bracket a minus 1. And then is equal to a quarter bracket a plus 6 a half, you put A. What is your A? Use the improper fraction. 32 over 7 plus 2, 3 over 4, 32 over 7 minus 1 is equals to a quarter. 32 over 7 plus 6. Check for yourself. How many solutions? One solution. Because A can only be 4 and 4 out of 7. That's it. And not any other value. And not any other value. If you put another number, your check will be wrong. That's what that means. All right, the last two are word problems. I am just going to read and write the equation. You are going to solve, you're going to check, you're going to say these two things. Here, you will name the solution, you will justify. All right, let's read the first one. Hesse is thinking of a number such that when twice the number is added to 3 times 1 more than the number. So what is happening to the number? Twice the number. So twice the number is added to 3 times 1 more than the number. To 3 times 1 more than, so then the number times 3, okay? She gets the same results. Same results means equal when she multiplies 4 times 1 less than the number. 1 less than the number. So that's the equation you're solving. Okay? So there. I have done the equation for you. You write it and solve it over there. So that means reading is important. You must know how to read. I don't know how else to tell you. You must know how to read. Challenge yourself. All right, where is the last one? I don't know. Where is the last one? Maybe it didn't come out. It disappeared. I don't know where it went. Okay. I will show you from the computer because it was there. Shwe. Come on. This is weird. I thought I printed it. Okay. Maybe we'll have it as part 2. Come on. Okay, I'll send it as part 2 when it comes out, okay?